According to the most widely accepted cosmological theory, our universe began roughly 13.8 billion years ago with the Big Bang, emerging from an extremely hot and dense state and has been expanding ever since. Based on our current physical models, we can trace the presumed chain of events back to the first moments after the Big Bang. What we do not know, however, is what specific event actually brought our universe into existence. According to some models of quantum cosmology, a universe could emerge from a quantum vacuum fluctuation, effectively from nothing. One possible explanation, then, is that our universe may have originated in something like this way. But if cosmological models allow an entire universe to suddenly emerge from the quantum vacuum, a rather bizarre question arises. Could a complete human brain also emerge from nothing in the same way? Although Ludwig Boltzmann originally proposed the idea in a different form, the basic concept is essentially the same. It is possible that you, watching this video right now, are such a Boltzmann brain, and that your entire life up to this point is nothing more than an illusion. In reality, you never grew up, never learned to read, and never lived through the life that supposedly led you to this moment. You and all your memories came into existence just an instant ago, with no real past. Everything you remember, your childhood, school, your friends, even the previous moment, exists only because your brain happened to emerge from nothing in precisely this configuration. This is already a deeply unsettling possibility, but it doesn't end there. Boltzmann brains are generally thought to be extremely fragile. If such structures can arise at all, they would probably be very short-lived, collapsing back into chaos almost immediately. So if you are such a fluctuation, there is no guarantee that you will still exist a moment from now. Your entire conscious life is compressed into a single instant. This one moment, here and now, as you watch this video. In that case, nothing beyond what is happening right now is real. The past is merely an illusion, and the future may never arrive at all. Can you prove in any way that you are not such a Boltzmann brain? Of course, this is a rather bizarre idea. It seems far more plausible that the universe actually exists, even if it somehow emerged from nothing. But there is a problem. The universe is full of brains. Do we really need hundreds of billions of stars, galaxies, and an unimaginable number of planets just for brains to emerge somewhere? The human brain is an incredibly complex machine, but even so, it is immeasurably simpler than the universe as a whole. Its mass is also incomparably smaller. In terms of complexity, mass, and energy content, a human brain is an almost insignificant structure compared with an entire universe. If we accept the possibility that a universe could emerge from a quantum vacuum fluctuation, then it seems reasonable to suppose that much smaller fluctuations capable of producing brains could occur far more frequently than a fluctuation large enough to produce an entire universe. On purely statistical grounds, then, the spontaneous emergence of an isolated conscious mind, a Boltzmann brain, might seem more likely than the birth of an entire cosmos. And this leads to a deeply unsettling philosophical question. If simpler fluctuations are far more common, isn't it conceivable, or perhaps even more likely, that you, watching this video right now, are such a Boltzmann brain, and that the reality you experience is nothing more than an illusion? The standard objection to Boltzmann brains is cognitive instability. In short, if you really were a Boltzmann brain and the world around you were merely an illusion, then the laws of physics would also be part of that illusion. In that case, however, you could not use those laws to argue that you are a Boltzmann brain, because that would be circular reasoning. If you really are such a Boltzmann brain, then you know nothing about the external, real laws of physics. You cannot know whether quantum mechanics applies there, or whether fluctuations capable of producing universes or Boltzmann brains from nothing even exist. However, this is not a strong argument against Boltzmann brains. It merely tells us that we cannot use the physical laws of the world we observe to argue in favor of them. Boltzmann brains would be extremely short-lived. Moreover, for such a brain to believe that it has a genuine past, it would have to emerge with a completely coherent set of memories and a plausible personal history. In other words, the fluctuation would have to create not only the brain itself, but also the incredibly precise internal structure encoding its entire life story. This kind of fine-tuning seems highly improbable. However, there may be a kind of intermediate solution, a universe capable of thinking like a human brain, but one that, unlike a Boltzmann brain, remains stable and evolves in roughly the same way as our universe. The main difference would be that such a universe could be much smaller and simpler than the universe we currently observe. But what would such a universe actually look like? According to our current understanding, the universe is not really made of particles in the traditional sense, but rather of what we might call pure mathematics. Our most successful framework is quantum field theory, QFT, according to which every type of particle corresponds to a field, and a particle itself is an excitation of that field. In this model, fields are often compared to the surface of water, with particles resembling waves traveling across it. This is a useful analogy because it helps us visualize the basic idea, but it can also be misleading since these field excitations are fundamentally unlike actual waves on water. A more precise way to put it is that particles are states of fields that can be described mathematically, and our world is the total state of all these fields. As time passes, this state continuously transforms into new states according to certain rules. So, if we look at the world through our most fundamental physical descriptions, what ultimately remains are numbers, states, and rules of transformation. From this perspective, whether we use quantum field theory, string theory, twistor theory, or some other framework, the basic idea remains the same. In this sense, we can think of the universe at its deepest level as pure mathematics. In some ways, a thinking brain universe would be very similar to our own universe. The difference is that instead of particles, it would be made of some other kind of fundamental building blocks. Anything that, when combined, could form a structure capable of thinking. Like our universe, this universe would also be governed by physical laws that determine how these fundamental elements behave. Ultimately, the situation would be very similar to our own universe, since this world too could be described as pure mathematics. Its fundamental building blocks, its particles, would have states that change according to certain rules. The only difference is that instead of galaxies and planets emerging and evolving, this universe would give rise to thoughts and mental structures. Such a universe would be much simpler and cheaper than the universe we currently observe. If someone wanted to create an optimal simulation of our world, it would be enough to simulate only the observers. From this, we might conclude that the most efficient simulation would be a gigantic brain, a fragmented consciousness existing as billions of separate observers. A single enormous brain like this would be orders of magnitude simpler than a complex universe filled with galaxies, stars, planets, and countless other brains. Therefore, purely on statistical grounds, it seems much more likely that such a brain universe could emerge from nothing than a universe as vast and complex as the one we currently observe. The universe as we know it has another deeply puzzling property. It appears to be extraordinarily fine-tuned for the emergence of life and conscious observers. If the masses of certain particles were even slightly different, or if the gravitational constant had a different value, the conditions necessary for life as we know it might never have arisen. We do not have a definitive explanation for this apparent fine-tuning. One common response is the anthropic principle. If the universe were not compatible with conscious observers, there would be no conscious observers here to ask why it is the way it is. But this alone does not explain why we seem so lucky that a universe so well suited to our existence emerged from nothing. This is one reason why many scientists consider the possibility that we live in a multiverse. Countless universes could emerge from nothing, each one slightly different. The vast majority might be unsuitable for intelligent life, but every once in a while, one could appear in which intelligent beings like us are able to evolve. In that sense, God not only plays dice, he plays the lottery, and we, the conscious observers, are the jackpot. So not only might the spontaneous emergence of a universe as large and complex as ours be extraordinarily improbable, but an enormous number of universes might be required before even one of them happens to have the right conditions for intelligent life. But what about brain universes? As I mentioned earlier, they would be much simpler and would, probably, require far less fine-tuning. I say probably because we could only know this for certain if we actually developed a working model of such a universe. Even without such a model, however, there are several strong arguments for why brane universes could be much simpler. Our computers are a good example of how extremely complex structures can often be built from very simple, fundamental elements and rules. Every modern computer, for example, can be constructed using a single logical operation called NAND. This operation returns true in every case except when all of its inputs are true. From this single operation, we can build any digital microprocessor and run any algorithm that such processors are capable of executing. If we assume that a human brain can be simulated on a digital computer, it would follow that a human brain could, in principle, be built entirely from NAND gates. I am not claiming that the human brain can necessarily be simulated on a digital computer, since this remains an open and controversial question. The point is rather that a thinking universe would probably require much simpler and more minimal physics than the universe we currently observe. Such a brane universe could therefore probably be described by far fewer and much simpler rules. Perhaps even a simple cellular automaton could be enough. The concept of cellular automata was introduced by John von Neumann and Stanislaw Ulam. These are simple mathematical systems in which the state of each cell is determined by the states of neighboring cells according to a set of rules. We can think of the cells as particles and the rules as physical laws. With the right rules, astonishing complexity can emerge from these simple structures. Some cellular automata can even be Turing complete, meaning they are capable of performing any computation. One of the best-known contemporary researchers in this field is Stephen Wolfram. He has proposed that even the physical laws of our universe might emerge from extremely simple underlying rules. We simply need to discover the right ones. Based on this idea, given the right fundamental rules and sufficient scale, there seems to be nothing in principle preventing brane universes from emerging. Such a brane universe could be much simpler and require far less fine-tuning than a complete physical universe, making its spontaneous emergence theoretically much more likely. If we use the classical simulation hypothesis to explain how our world works, for example, the fine-tuning of the universe, we immediately run into an uncomfortable question. Who created the simulation? If the answer is an advanced alien civilization, then the next unavoidable question is, how did they come into existence? We encounter a similar problem with creation. If God created the universe, then where did God come from? The problem with explanations like these is that they do not really solve anything. They simply push the problem one level higher without actually resolving it. A brane universe, by contrast, offers a more elegant possibility. Like the universe we observe, it could simply emerge from nothing. There is no way for us to prove that we are not part of such a brane universe. In this scenario, the entire universe would itself be a thinking brain, capable of observing itself only through its individual personalities. If the mind itself is the universe, there is no way for it to look at itself from the outside, because there is nothing outside it. What each of its personalities experiences as objective reality would merely be an illusion, an interface between separate identities. The brain itself would not even be aware of its own existence. In a sense, it would be living inside a dream of its own creation. Perhaps such a mind initially exists as a single individual and later fragments into many separate identities. But it would have no memory of this, because its memories, and therefore its past, could be just as flexible as its present or future. What matters is that at every moment it possesses memories of a consistent history. For a time, it might dream of a world filled with dragons and magic, and later of a world governed by strict physical laws. The previous world would simply disappear from history, as if it had never existed at all. In such an imagined world, the apparent fine-tuning of the physical constants would not be surprising at all, since this fine-tuning is precisely what keeps the illusion consistent. In fact, these constants might not even exist until someone measures them for the first time. Consider elementary particles, for example. An electron would not exist until someone observed it, because the electron itself would be part of the illusion, a story we use to make sense of our experiences and describe the patterns we observe in the world. Suppose we measure the mass of the electron and obtain a certain value. Later, we might discover that this value is incompatible with other physical laws of the world. In that case, the electron's mass could change, and that change could propagate backward into the past. From that point on, the electron would have always had this new mass, perfectly consistent with every other observation. With rules this flexible and a past that can be rewritten, fine-tuning would no longer be surprising, and there would be no need for billions of universes to explain it. This mechanism is somewhat similar to John Wheeler's idea of the participatory universe, according to which observers bring the past into existence through the act of observation. The difference here is that the past could be just as flexible as the future. Quantum phenomena such as non-locality or wave function collapse would pose no fundamental problem in such a world, because space, time, and matter themselves would all be part of the illusion. Things would only become real when the brain universe observes them through one of its individual personalities. No matter what experiment we performed, we could never prove the illusory nature of the world, because doing so would require us to outsmart our own mind, which would be impossible. Especially if the past itself could be freely rewritten whenever necessary. Before we venture too far into quantum mysticism, however, it is worth pointing out that although this model does not rule out the possibility that our consciousness could influence the world, this does not mean that such influence is actually possible. Since we could know nothing about how such a unified mind operates, it is entirely possible that we would have no influence whatsoever over the evolution of this illusory world, or at least no more influence than the laws of physics already allow. A brain universe like this could also offer an explanation for one of the most remarkable features of our reality: the fact that the laws of physics are so elegant, orderly, and comprehensible. Albert Einstein famously wrote in 1936, "The eternal mystery of the world is its comprehensibility." In everyday life, we take it completely for granted that the world behaves in mostly simple and predictable ways. If we throw a stone, we can roughly predict where it will land. If we place a glass on a table, we know that it will not simply disappear a moment later. But there is nothing self-evident about this. The laws of physics could have been different. They could have been chaotic, or at least so complicated that they could only be described by enormously complex rules. The classical answer to this mystery is once again the anthropic principle. Intelligent life might not be able to emerge in a universe governed by extremely complicated and unpredictable laws. Moreover, since our brains evolved precisely to predict what happens in the world, it is perhaps not surprising that we perceive the laws of physics as simple. In a brain universe, however, the situation is reversed. The laws of physics could partly emerge from the operating principles of the mind itself. Only a reality that the brain is capable of imagining could come into existence. This could explain why we find the laws of physics beautiful and simple. It would be a fascinating experiment to construct a theory of everything that begins with such a brain universe and attempts to derive the laws of physics from it. Donald Hoffman is working on a somewhat similar model. He proposes that the fundamental building blocks of nature are not particles, but conscious agents. And from this starting point, he attempts to recover features of physics, ultimately connecting the model to the level of elementary particles. Another interesting question arises: what happens to the human brain in such a brain universe? According to the dominant physicalist view in neuroscience, conscious experience depends on processes in the brain, and consciousness emerges from neural activity. In a brain universe, however, consciousness would be fundamental, while physical reality would merely serve as an interface between different minds. In that case, the brain itself would be just as much a part of the illusion as everything else. At first glance, it might seem reasonable to assume that by examining the brain in sufficient detail, we could determine whether the material reality we observe is the ultimate, objective description of the world, or whether we actually live inside such a brain universe. But the situation is not quite that simple. Imagine that we have a brain scanner capable of recording neural activity with extraordinary precision. We place a test subject inside the scanner and ask them to choose between a red pill and a blue pill. If the information recorded by the scanner allows us to trace the entire decision-making process, and that process turns out to be completely deterministic, this might seem to rule out both free will and the existence of fundamental consciousness. The scans are performed, and the scientists are able to reconstruct the decision-making process from the subject's neural activity. But does this really prove that consciousness is nothing more than a product of the brain? As we have already discussed, in such a universe, elements of reality would only come into existence when they are observed. So when the scientists analyze the data themselves would only come into existence at that moment, and naturally, they would be perfectly consistent with what is observed. Therefore, we could not rule out the possibility that the decision was actually made by a consciousness existing outside the illusory physical reality, and that the observed reality subsequently adjusted itself to remain consistent with that decision. To get around this problem, the scientists devise a new experiment. Using the information collected from the brain, they try to predict in advance which pill the subject will choose, and then place their prediction inside a sealed envelope. After the subject makes the choice, they open the envelope. If the prediction matches the actual choice, it might seem to demonstrate that neither free will nor fundamental external consciousness exists, and that the brain operates deterministically, just as Laplace imagined in his famous thought experiment known as Laplace's demon. But there is a way around this problem as well. If the past can be freely modified, then even this experiment cannot provide a definitive answer. Imagine that, based on the data, the scientists predict that the subject will choose the blue pill, but the subject freely chooses the red pill instead. No problem. The outcome of the choice propagates backward in time and changes the prediction inside the sealed envelope from blue to red. Through the synchronization of mental models, every scientist involved would also remember that red had always been the predicted outcome. By allowing retrocausality, the possibility that the past itself can be altered, we can deal a final blow to Laplace's demon and determinism. At the same time, however, we also ensure that we can never truly prove or disprove whether we live in such a brain universe, perhaps in the mind of God, or whether the reality we observe is actually the ultimate, objective description of the world. The existence of free will could only be falsified if scientists were able to control the decisions of their test subjects. In such a world, there would have to be some physical or other fundamental principle preventing this kind of control. Perhaps some quantum mechanical phenomenon plays a role in the functioning of the brain, or perhaps there is some other factor involved that we have yet to discover. All of this leads to a clear conclusion. We cannot rule out the possibility that we live in such a brain universe, that what we perceive as objective reality is merely an illusion, and that all of us are parts of one enormous mind. And this is precisely why the brain universe hypothesis is not a scientific theory. According to Karl Popper's influential philosophy of science, a theory must in principle be falsifiable by observation or experiment to qualify as an empirical scientific theory. If a hypothesis cannot be falsified, it falls outside this criterion. It is worth noting, however, that several widely discussed ideas in modern physics contain elements that are currently beyond experimental testing. Examples include certain versions of the multiverse hypothesis and extra spatial dimensions at scales below the Planck length. So while we cannot prove that we live in a brain universe, perhaps we have established reasonable grounds for not dismissing the possibility entirely. For this reason, I believe that the simulation hypothesis, in its broader sense, the idea that the world we observe may not be the fundamental level of reality, and that some deeper objective reality may exist beyond it, deserves serious philosophical consideration and scientific discussion alongside other speculative ideas about the fundamental nature of reality. Could it be that the universe we see around us is not actually the fundamental level of reality? Could we all be parts of a single, enormous mind, while what we experience as space, time, matter, and the laws of physics is merely the internally consistent world created by that mind? Of course, we cannot prove this, but as we have seen in this video, perhaps ruling it out completely is not so easy either. If these questions fascinate you, and you would like to explore how relativity, quantum mechanics, consciousness, artificial intelligence, and the simulation hypothesis might fit together into a single, overarching picture of reality. You can download my book, Simulated Reality, for free. You will find the download link in the video description. And if you enjoyed this video, please give it a like and subscribe to the channel. It may seem like a small thing, but it really helps these videos reach more people who are interested in science, physics, and the deeper nature of reality. And finally, one question. If you had to choose between two possibilities, which would you consider more likely? That mind emerged over billions of years within a vast, finely tuned physical universe, or that mind is fundamental and the universe we observe is simply the reality it creates? Let me know what you think in the comments. I'm curious which possibility you find more plausible.